Okay, so on the axes below, we're graphing two functions. The function y equals the absolute value of x, and then y equals 3 times the absolute value of x. And we're looking at the interval where x is greater than or equal to -3, but less than or equal to 3. So we just, we can set up tables here for each function. Y equals the absolute value of x. And we plug in our x values from -3 all the way up to +3. So we have all the integral values there. And in this case, when we plug these x values in, we plug them into this formula. So -3, you take the absolute value of that and get y. You get +3. -2 gets +2, -1 gets +1, and then 0, 1, 2, and 3 all remain the same. Then we can plot these on our graph, right? We have 0, 0, 1, 1, this will be the height of 1, 2, 2, right here, and then 3, 3 will be there. And then over here we'll have the same thing, really, except the inputs will be negative, but the outputs will still be positive. So we kind of get this V shape right here, and get used to that with absolute value. Whenever we have absolute value functions, we get some variation of this V shape. And our other equation is going to be very similar, except it's y equals 3 times the absolute value of x. So here, when we plug in our x values, you can almost imagine what's going to happen. We plug in -3, we plug that into the absolute value, so that becomes 3, times 3 becomes 9. -2, absolute value of that is 2, times 3 is 6. -1, the absolute value of that is 1, times 3 is 3. 0 times 3 is 3. 1 times 3 is 3 again. 0 times 3 is 0. 2 times 3 is 6, right? Because the absolute value of 2 is still 2. 3 times 3 is 9. So we get a very similar kind of function here. We still have 0, 0, but then what we have is the point 1, 3. Instead of 1, 2, right, we have 1, 3. It's a little bit steeper. Instead of 2, 2, right, what do we have? Well, we have 2, 6. So 1, 2, oops, sorry about that. This 1, 3 would actually be here, right? 1, 3, -1, 3 is symmetrical. 2, 6, so 4, 5, 6. So 2, 6 would be here. -2, 6 would be here. And then 3, right, we have 7, 8, and then it would be off the chart here. But since these are really just two kind of straight lines that meet at 0, 0, you can still plot it here by connecting those points. And now we have y equals 3 times the square root of the absolute value of x. So as that number gets higher that we multiply the absolute value of x by, our graph grows at a faster rate. So we get this narrower type of graph. Let's keep going. Which relation is a function? Remember that a function maps x values, or inputs, to y values and outputs. And what's important is that each input has precisely one output. So that's what a function is. It maps each x to a specific y value. So if we have one x value is going to two different y values, y1 and y2, right? That's not a function. This can't happen. So this is not a function. It's a different type of relationship. So we're going to look at these lists, and if we see an x value being repeated with two different y values associated to it, then it's not a function. You can find it pretty quick here. We have -2 twice, and -2 goes to 2 in the first case. So our -2 is our x value. It maps to 2 in one case, so -2, 2, and the other point, -2, 4. It goes to 4 in the other case. That's not a function. So 2 is our answer. What is the value of the expression a to the third power plus b to the 0 power squared when a equals -2, and b equals 4? Well, a to the third power, -2 to the third, is -2 times -2 times -2, which is -8, plus b to the 0, anything to the 0 power is 1, right? And then we square that. -8 plus 1 is -7. If we square that, we get 49. So here our answer is 2, which is the graph of the absolute value of x plus 2. Well, here we can recognize it immediately as choice 3. The absolute value function looks like this V shape. If we add 2 to it, the whole graph shifts up. But here, you don't really have to know that or memorize that. you could just plug this into a table where x and y are a couple of key values to figure out if you found the graph that matches. So let's choose 0, -2, and +2. So here if we plug in 0 to this equation, we get 0 plus 2, or 2. So it has to have the point 0, 2, which it does. So choice 1 can still be correct, so could choice 2, and so could choice 4. They all contain that point. But if you plug in -2, the absolute value of -2 is just what? Well, that's 2. Plus 2 is 4, so here we should get 4. So we need to have that point -2, 4. This graph has it, right? This graph right here also has it, so we haven't found out yet. 4 does not have it. We eliminated one choice. And here it looks like 2 has it as well. So, okay, we're not sure yet. Plug in 2 and we should get 4 as well. So here, graph 1 does not have that value. Graph 2 does, so we need to test more values. Let's just test, I don't know, let's test 3. If I plug in 3, I should get 3 plus 2 is 5. Graph 3 has it, but this graph does not have 5, has a much higher point, so that's out. So just by testing, x values, by plugging x values into your equation and seeing what points those form, because these are each points, 0, 2, -2, 4, 2, 4, and 3, 5. If those points aren't on your graph, then it's not your graph, your function, right? Just test them out. Okay, let's keep going here. Let's get some more problems out. Which verbal expression can be represented by 2 times x minus 5? The first one says 5 less than 2 times x. Well, that would be 5 less than 2x, like this. But really, we have, if we distribute this, 2x minus 10. So this one, choice 1's out. 2 multiplied by x less than 5. Well, 2 multiplied by x less than 5 would be this, which is not what we have. Then it has twice the difference of x and 5. That seems pretty good to me, because the difference of x and 5, that would be x minus 5, right? Difference means subtract. And we're doubling that. Oops, sorry. So we're finding twice the difference of x and 5, and that seems to make sense to me. So I'm going to pick that. Let's just check the last one. The product of 2 and x, okay, and then decreased by 5. Almost what we have, except again, x minus 5 is in parentheses, and if we distribute that 2, it would be the product of 2 and x decreased by 10, because 2 times -5 is -10. So there, choice 3 is the clear answer. An example of an algebraic expression is, well, an expression is lacking an inequality or an equality sign. So those can't be expressions. Those are inequalities and equations. 1's an equation. 2 says 3x plus 4y minus 7. There's no equality, no balance, no inequality, as well, sorry. So that's an expression. Here our answer is choice 2. Let's keep going. What is the value of, and I'll write this out, the absolute value of 4 times -6 plus 18 over 4 factorial? Okay, well, 4 times -6 is -24 plus 18. What's that? Well, that's just -6, right? And we have -6 over 4 factorial. 4 factorial is 4 times 3 times 2 times 1. We're taking the absolute value of that. Well, one nice thing that we can do here is realize that 3 times 2 is 6. So a quick way to think about this is we have -6 over 4 times 6 times 1. Reorder that, so it's 6 times 4 times 1. And then we cancel out these two 6's to get -1. So we get -1 over 4 times 1, or 4. It's the absolute value of -1 over 4, or 1/4. Choice 1. Here, which graph does not represent a function? Well, a function, if you draw a vertical line through your graph, a function only crosses that line once. So in all cases here, anywhere you draw a vertical line, you're going to cross once, except for choice 3. We draw it here, or here, or here, or really anywhere, except at the vertex. We get 2 results. So that's not a function, right? Each x value has to have only one y value with it, and each x value you pick here has 2 y values. So that's not a function. Okay, let's finish this up. All right, the graph of the absolute value, so y equals absolute value of x plus 2, is shown here. Which graph represents the opposite of the absolute value of x plus 2? Well, let's just plug in some x values to get a sense of what's going on here. So x will be, let's do -4, let's do 0 and 4. Let's plug those values in. If we plug them into our equation, and now our equation is this here, so it's, let me fix this here. It's not y equals the absolute value of x plus 2, that's for this right here. We're looking at y equals the -1 times the absolute value of x plus 2. So if I plug in -4, I get -4 plus 2, it's -2. The absolute value of that is 2, then take the opposite, we get -2. Plug in 0, I get -2. Plug in 4, I get -6. So let's look for these points. We should have a graph with -4, -2, right? This doesn't have that. This doesn't have that. Choice 4 and choice 2 look like good candidates. We have -1, -2, -3, -4, and -2. And here we have -1, 2, 3, 4. Doesn't have it. So 4 must be the graph of that. And you can see that it's kind of like the upside down version of the original graph, right? And that makes sense. We're inverting it, or taking, in a sense, the upside down of it. So here, I notice my test values for x. I didn't choose 1 or 2 even, but -4 and +4 and 0. By plugging those in, we form these 1, 2, 3 points that we can quickly check to see, which graph has those points. That's graph 4. And last, we have which graph represents a function. So a function, right? Again, when you draw a vertical line on your graph, everywhere you draw a vertical line, it's only cross the graph once. If it crosses more than once, that means your x value, whatever x value you have, has at least more than 1, right? Like this x value here too has these 2 values associated with it. That's not a function. So choice 2 is not a function, right? Choice 3 is not a function. You can draw those vertical lines and cross it more than once, but choice 1 is okay. Anywhere you draw that vertical line, you're only going to cross once. Sorry about this. Whoa, fix that. So that's our answer. All right, hope that helped.